Okay, girls, you've all been emailed this worksheet, exercise 3D, simple harmonic equations, simple harmonic motion, time equations. We're going to go through some of the questions on this sheet today. Okay, the first question we're going to look at is question 10. Okay, now you'll notice with these that there is no equation, okay? So we will have to draw a diagram. So exercise 3D, the first question, it says a particle moves in simple harmonic motion about the origin with period pi on 2 seconds. So it's simple harmonic motion, period is pi on 2 seconds. It says initially, so when t equals 0, the particle is at rest, so v equals 0, and initially as well, the particle is 4 centimetres to the right of the origin. So we've got the period, when time is 0, velocity is 0, and the position is at 4 centimetres to the right of the origin. You have to write down the displacement time and velocity time functions. Displacement versus time function, in other words, x equals something t. It's simple harmonic motion, so it's going to be a cos curve or a sine curve. I would make this one, we've only really done cos curves. Last video you got, I did do a sine curve for you. Now, depending on where the particle starts, you can choose a sine or a cos curve if you want. It doesn't have to always be a sine curve for simple harmonic motion, because the cos curve is just the sine curve shifted 90 degrees. Okay? So you choose the function that is the easiest to use if they haven't given you an equation. So for this one, because the particle starts at 4 centimetres to the right of the origin, I'm going to do a cos function, because cos functions do not start at 0. The normal cos function starts at 1, doesn't it? And then it goes down. But why would this, if this starts at 4, what's the amplitude of your cos function? 4. So we're going to say, right, general form is a cos nt. Look, we've got no shift here plus alpha. You know how it's nt plus alpha? There is no shift, and there's no shift. So there's no shift sideways. There's no shift up or down. So this is just 4 cos something. But we've got to work out what n is, girls. So what was the period of this? It's in the question. Period is pi on 2. So 1 full cycle is pi on 2. But I have to work out what n is in this equation. So we know that period, what's the formula for working out the period? 2 pi on n. So 2 pi on n is equal to whatever your period is. Now don't be confused with this. 2 pi on n gives you your period, and your period's pi on 2. So don't worry that you've got the pi's in 2 places, okay? So your period, the formula for period is 2 pi on n. I'm trying to work out what n is, girls, to write out this equation here. Period is 2 pi on n. They've told us the period's pi on 2, so we put 2 pi on n equals pi on 2. Now solving for n, you get, I'm going to flip both sides, n on 2 pi equals 2 on pi. Are we okay with that? If I take reciprocals of both sides, flip both sides. So therefore, what does n equal? Well, it's 4 pi on pi, which is 4 pi on 4 pi on pi, which is 4. So the period is 4 pi on pi, which is 4. So therefore, my equation for x, I know that my amplitude is 4. Yeah. So I can see here that my amplitude is 4. So it's 4 cos 4t. So that is my equation for my displacement time function. You wouldn't go and choose the sine function here because it doesn't start at the origin. Okay, it's a cos function. Amplitude 4, it starts there, which is great. There's no sideways shift, so I don't need my plus alpha. There's no up or down shift as well. Now what we're going to do today, we're going to do a number of problems, and I don't want you doing up and down shifts. you can actually always start around the origin and not do an up and down shift, but then you can add your up and down shift later on in the question. No, well, it won't have one because it says here that when time is zero, it's 4 centimetres to the right. So it's fine. And it's simple harmonic motion. Look, there'll be, all right, I'll tell you, when we do a tied question or something like that, or did you watch the last video that I sent? The one where the particle went between 15 centimetres and 55 centimetres. I sent it yesterday. All right. Right is the velocity time function. So if that's the displacement function, then velocity is what? The derivative of that, which is what? 4 times, anyone? Differentiate cos 4t. Negative sine 4t times 4. So velocity is negative 16 sine 4t. So we've done part A. We've written down the displacement time, and the velocity time functions. Are we okay with that? All right, now for part B. I think part B, you girls should be okay, but we'll do it anyway. So once we've got that, we can answer the rest of our questions. Find how long the particle takes to move from its initial position to a point 2 centimetres to the right of the origin. Now, I want to know the time. This would be about 2 centimetres to the right, about there. Guys, I want you, before you do this question, if this is pi on 2, what's this? Good. What's this? Pi on 8. So your answer to the next question is smaller than pi on 8. So we're expecting pi on 10 or pi on 11, pi on 12, something like that. Does that make sense? All right, so it says, how long does the particle take to move from its initial position to a point 2 centimetres to the right of O? We just want to find time when x is, what? 2. So we use our displacement function. 2 equals 4 cos 4t. So 2 on 4 is a half equals cos 4t. We just want the first time. So 4t, acute angle, 4t is what? Cos of what is a half? Cos of something is a half. Cos of 60, which is pi on 3. That's, look, cos of 4t is a half. Look, I know it's quadrant 1 from my diagram. Do you know how I know? Quadrant 1, 2, 3, 4. So I'm not going to do both. I don't have to do, well, actually, look, we'll do them both. Cos is positive in quadrants 1 and 4. What would be the quadrant 4 thing? Pi on 3. Pi on 3. Well, all the way round is 2 pi. It's 2 pi minus, it's 2 minus a third. Yeah, 5 pi and 3, because 6 on 3 is 2. Sorry? Because it's quadrant 4.
Oh, yeah.
Which is 2 pi minus, so it's 5 pi and 3. Look, I don't think we're going to need that, but we'll just see. So therefore, time is pi on 12 or 5 pi on 12. Now, we estimated that it would be less than pi on 8, smaller than pi on 8, and it is. We've got time is pi on 12. Therefore, it takes pi on 12 seconds to reach x equals 2. Are we okay? Yeah. All right. And then it says, how long does it take to move from the initial position to a point 2 centimetres to the left? So we want find t when x is what? Negative 2. So we've got negative 2 is 4 cos 4t. Guys, it's going to be the same as the other one, but what quadrants? Oh, actually, let's look at the diagram. One sec. I'm going to redraw the diagram over here because I really like you looking at the diagram all the time. So I'll bring the diagram back down. I've drawn it again. See, 2 centimetres to the left, can you see where it is? So that's quadrant 1, quadrant 2, 3, 4. So we're expecting between, that was pi and 8, we're expecting between pi and 8 and pi and 4, and we're expecting between pi and 4 and whatever that is. I can't think. Okay, no, it's 3 pi and 8, okay? So we get negative a half is cos 4t. We know that's quadrants, what? 2 and 3. We know the acute angle 4t is 60. So the quadrant 2 and 3 answers are, drawing it here, it's really good to draw it, girls, nice and visual. The quadrant 2 and 3 answers, especially when you got pi's. Pi minus pi and 3, that's 1 minus a third, is 2/3 pi. And then you've got 1 plus a third, because see, girls, this is pi here. So 1 and a third is 4 pi and 3. And dividing those all by 4, we get 2 pi and 12, which is what? Pi on 6. And we get 4 pi on 12, which is pi and 3. Yeah. So therefore, which one's this one? If that's pi and 8, and this one, I know it's a bad diagram, all right? Should be more there. That's 3 pi on 8. Where's your, see, that's pi and 6, that's pi and 3. So what was the question? How long does it take? Which answer do you take? Therefore, it takes, yeah, pi and 6 seconds. Now, the reason I'm using the diagram is that we're going to use it, I'm going to go to one of the harder questions. It takes pi and 6 seconds to reach x is negative 2. 2 metres to the left. And the next question, are we okay?
Is that because it's first?
Yes, it's the first one. And that would be the other one. That's pi and 3 there. See, if that's pi and 4 and that's pi and 2, that's pi and 3 there.
So it's always the first.
Well, it says, yeah, how long does it take to move from the initial position to there? You've got to read it in context with the question. So they only wanted to know from the initial position to that. If they wanted to know the 2 times when it's there, you put both answers. But they wanted to know how long it takes to reach that from the initial position. That's why. Okay? And the last question, find the first 2 times when the speed is half the maximum speed. Let's look at the diagram. I'm going to draw the velocity equation. So I'm going to write down what the velocity equation is. It's negative 16 sine 4t. See, for the next bit, part C, find the first 2 times when the speed is half the maximum. You can tell me already the maximum speed. Half of 16. Girls, if I draw that, let me draw that function. That's the velocity curve. What is it? Negative 16 sine 4t. That's a negative sine curve, so I draw it. The period will be the same as the other one, pi on 2. And the amplitude is 16. There's negative 16. So tell me when we're half the maximum speed. Maximum speed 16. Or minus, actually speed, we've got to take both. The positive 16 and the negative 16. So in other words, find t when x is what? Plus or minus 8. Half the maximum speed equals a half of 16, which is 8. Now, I have to do plus or minus 8 the 2 times. There's more than 2 times.
There's the first 2 times.
Find the first 2 times. So, thank you. So, yes. Can you see it's negative? There we go. So, find t, not when x, when v. What's wrong with me? Find, that's okay. Find t when v is, you can see it's negative 8. Because look, these are the first 2 times and they're the next 2 times and it's speed, so negative doesn't matter. We don't care if it's going left or right. So find T when V is -8. Very good. See how the diagram helps you.
Why do we care about quantity then?
The first two times. The first two times are there and there. There's actually 4 times in the period when you're half the maximum speed. They want the first 2 times. Hence, girls, the diagram is your best friend in these questions. It lets you know whether you're doing the right thing or not. And they're very easy to draw. It's just a sine curve or a cos curve. And you'll know if your answers are correct or not. Because I need 2 times that are less than pi and 4. So I'm expecting pi and 6s or pi and 10s or things like that.
So
All right?
half max speed.
Well, the maximum speed's 16. It's the maximum of the velocity curve.
Yeah.
Well, that's the max, and that's the max. 16? Because that's what the question says.
Oh, okay.
All right, so now I go -8 equals -16 sine 4t. -8 over -16 is positive 1/2, is sine 4t. Sine of what is 1/2? Acute angle 4t is, well, sine of 30, so it's pi on 6. I want quadrants 1 and 2. So therefore, if I draw my little quadrant 1 and 2, pi on 6, pi on 6, I've got that 4t is pi on 6 and 5 pi on 6. Therefore, t is pi on 24 and 5 pi on 24 seconds. They are both less than pi on 4
Can we just put seconds after that?
seconds.
Do we have to do it separately?
No, that's fine. Good. Okay, girls. Okay, that was question 10. Next one I want to look at is 23. These are the questions I've been waiting to do. The tide questions and the temperature questions. Okay, it says the temperature at each instant of a day can be modelled by a simple harmonic equation. Remember, simple harmonic, we're just looking for a sine curve or a cos curve, oscillating between 9 degrees at 4 a.m. and 19 degrees at 4 p.m.
So 9 plus 9.
Okay, yes, we do know that it goes between, I'm just going to do a little thing over here. It goes between 9 and 19, right? 9 is at 4 a.m. and this is at 4 p.m. Now, I can do the graph with 0 there and time there, and I can go, yes, halfway between those is 14, and do 14 as my halfway mark. I can do this, but I don't want to. And 19 and 9, and the temperature, it's 9 degrees at 4 a.m. and 19 at 4 p.m. I can do it like this, that time is 4 a.m. and that this time is 4 p.m. But if you do it like that, your equation has to have a plus b. Okay? I prefer not to, but I can do it both ways for you. All right, now, see, girls, I've drawn it. The low temperature of 9 degrees is at 4 a.m. in the morning, and the high is at 4 p.m. They've told you simple harmonic motion, therefore it's a sine curve or a cosine curve. Tell me what time this is when you're...
Upside down.
It is. Tell me what time it will be when you're back at... What's the next time here? 4 a.m., 4 p.m. is 12 hours. What will this be? 4 a.m. on the next day. So, you can, girls, we've got two choices. You can do it like that, or, now that is the proper curve, but this is what I prefer to do. I prefer to just draw it like this with no shift. This is 0. What's the amplitude, girls? The amplitude's 5. So I like to go from 5 to -5, but I know that 5 is really what temperature? So I'm just going to put this on the side, and -5 is really 9, and 0 is really 14. So what you can do is just work with this But whatever answers you get, you'll add 14 onto them if I'm asking for temperatures later. All right, so it makes it easier to write the original equation first. So we've got 4 p.m., 4 a.m., 4 a.m. Okay, now I've got this curve is the same as that, but I've just brought it so that the center of motion is the t-axis, but 0 degrees, 0 really means 14, -5 really means 9. Does that make sense? I've just shifted this whole thing to make this 14. I've put it at 0. That is the center of motion. So 0 is really 14, 5 is really 19, and -5 is really 9.
Yeah, that's easy.
I think it's easier so that you're just drawing it around 0. So therefore, but you've got to be careful. It's just in the final step of the question. Your answers won't be the correct temperature. You've got to add your 14 onto them. That's all. So you can choose to go either way, try and write that equation out, or it's easier to write this equation out, but knowing that 0 is 14. Now, whenever I talk about the graph, I've got to use this graph. When I interpret the question and answer it at the end, I'll add the 14s on or whatever. Now, if you're going to find it too hard, we'll just use the top one, but let's try this first. Okay, it says find correct to the nearest minute the times between 4 a.m. and 4 p.m. when the temperature's 14.
How do you know which 4 a.m. or which 4 p.m.?
No, 4 a.m., 4 p.m. I think they just want the first one. Find the times between 4 a.m. Okay, well, that must be here. Now, before I start, I don't even know what the equation of this graph is. X is A cos nt. Is it a cos curve? Yeah, it is. So, what is it? It's a cos curve. It's not a sine one. It doesn't start at 0, but it's the negative one. What's the amplitude? -5 cos. Let's work out what n is. Period equals 2 pi on n. You can see the period from there to there. What's the period? How long does it take for one complete curve? 24 hours. So therefore, the period, which is 2 pi on n, is 24 hours. Therefore, n is what? 2 pi on 24, which is pi on 12. So your equation is x equals -5 cos pi on 12 t. Now, that's if you use this one. If you decide to use the top curve, you just go plus 14 on the end, if you want. See the difference? All right? So that's for this one. If you want to do that one, you would put plus 14. This is the equation of this one. If you want to write the equation of this one would be x is -5 cos pi on 12 plus 14.
Miss, why is the amplitude negative?
The amplitude's not -5. The amplitude's 5, but it's a negative cos curve.
And then we just subbing that 14 equals x.
Now, wait a sec. No. For the top one, you would substitute 14 is x. For the bottom one, you'd substitute... Sorry? All right. But you have to know that 0 is 14 degrees. All right. So, look, I think it's easier to do your center of motion around the center, to draw your graph around the center. Yes, I did forget the t for that one. Okay. So, -5 cos, this one's pi t on 12 plus 14 if you were to use that one. I'm going to use the bottom one. Can I move down? So it says find correct to the nearest minute the times between 4 a.m. and 4 p.m. when the temperature is 14. If I'm using this graph, 14 degrees is really 0. So I just, so when temperature is 14, I'm putting x is 0 on this graph down here. You got it? So I'm putting 0 into this one. 0 is -5 cos pi on 12 t. What can I do now? Divide by? Divide by -5. I've just got cos pi on 12t is 0. Cos of what? 0, girls?
So this is what I don't get. Do you put -5 in here, or you put... Wait, this you have 2 t's and they both mean different things.
No, they don't mean different things.
When t equals... What?
Oh, temperature. When the temperature's 14, sorry, x is 0. Can you see that from that graph? So, girls, if you put 14 in the top graph, you're going to get 0 anyway. If you put temperatures 14 here, you're going to get 0 anyway. You're solving the same thing. So, all right. So cos of what is 0? Look at your graph, the normal cos curve. Yeah. So pi on 12t is 1. Don't we just want the first time? See, girls, I can put, what's the other one as well? Girls, I've made a mistake. Girls, I've made a mistake. Thank you. Pi. It's pi on 2, 3 pi on 2. But which one do you think I just want? Guys, sorry, I read this wrong. Cos of something is 0 here, not 1. So it's pi on 2, 3 pi on 2, so therefore t is what? Put the 12 up there and the pi down there. 6, and the other one, 12 and pi. What's that? 24 and 36 on 18. 18. Now, girls, what does time is 6 and 18 mean? It's 6. So looking back at the original curve, not 6 seconds, 6 hours. Guys, that's okay. That's time 0. So if you add, so therefore it'll be at 4 a.m. plus 6 hours. That first time is 4 a.m. plus 6 hours. It's actually pretty obvious it's 6 hours. Do you know why? The whole thing's 24 hours. Halfway's 12 hours. That's 6 hours. Got it? But that's okay. All good. 24 hours from there to there, girls. 12 hours is halfway. That's 6 hours. But it's good. We proved it. So 4 a.m. plus 6 hours is... Now, yes, you could have just done it from the graph. See how you got the graph?
How do you know that that's quarter way?
Because they're quadrants and it's a cos curve. It cuts, and because we've drawn it around 0, it's even better. See how I've got 4 a.m., 4 p.m.? That's halfway between 4 a.m. and 4 p.m., which is 10 a.m. Do you know what time this one is? 10 p.m. I need the graph bigger, don't I? Do you get that? Okay, so that's the first one. The other time would be, the other time's 10 p.m. if you want it. Do you get it? The other time would be 4 a.m. plus 18 hours, or just looking at your graph, you can see it's 10 p.m. Who doesn't get it? All right. Do you get that, girls? Yeah. Girls, do you get how I went 4 a.m., 4 a.m., 4 p.m., halfway between 4 a.m. and 4 p.m. is 10, and another 6 hours, because if that's 24, that's there. And then,
It's like doing 4 a.m. plus 18 hours would be 10 p.m.
There you go. Okay? So time is 6, time is 18. You've got to add that time onto the starting position. I'm drawing the graph again because I need it. All right, we've got 4 a.m. We've got 4 p.m. We've got 4 a.m. I'm drawing it again. We've got 10 a.m. We've got 10 p.m. Sorry, I know you can't see that very well. We've got 5 and -5 and 0, but 0 is really 14. -5 is really 9 and 5 is really 19. 7 degrees. Find correct to the nearest minutes the times between 4 a.m. and 4 p.m. when the temperature is 11. Now here's 11 here. You give me the corresponding X value, please.
Miss, Sarah made a good point. We only need to say for the other question the first one because it's not between the 4.
Yeah, I know. So I'll just put this one in brackets.
Yeah.
All right? If they say in the first 24 hours, I'll put that one in brackets. Okay, now, find the correct to the nearest minute the times between 4 a.m. and 4 p.m. when it's 11 degrees. Now, 11 degrees is 4. So when the temperature is 11 degrees, what's X? X equals what? Guys, 9 degrees is -5. -3. No? Girls, if you're finding that hard, you should go with the top equation. Because if you look at the top equation,
Because we've never seen it before.
all right, that's okay, that's okay. When you put 11 here, 11 minus 14 is negative 3. All right. And you can see it here. If 9 is negative 5, negative 4 will be 10, negative 3 is 11, negative 2 is 12, 0 is, okay. So we put that in, negative 3 equals negative 5 cos pi on 12t, and you get, what's negative 3 on negative 5? 3/5. This one is not exact. This is B. So this is B. All right, what have we got? Girls, you need your calculator for this one. So pi on 12t, the acute angle, you have to go shift to the minus 1 of shift cos 3/5. Because cos of what is 3/5? Cos to the minus 1 of 0.6? 3/5 is 0.6. Can I have an answer, please? All right, you can do it in, I want it in radians. Why do I want it in radians? Because the pi on 12 is radians. You should be getting 0.92725295218, I think. That's what that is. Now, girls, just looking at your graph, do I need to bother with the other quadrants or just quadrant 1? I want 11, it's here. I'm not going to bother with cos is positive in quadrants 1 and 4. If I need that, I'll have to do this other one here. Actually, I'm going to work it out anyway because you're going to need to know how to do it for a tied question, which is question 24. So what we're going to do, I know we should only be doing the first one, but let's do the first and the last so that, for example, if there's a boat in the harbour and the boat needs the water depth to be a certain amount, you need to do both times, all right, for a boat in a harbour. So I'm going to work out both times, that one and this one, because then you'll learn the skill for question 24. So therefore, we can say cos is positive in quadrants 1 and 4. We do know that we only need quadrant 1 for this, but we're doing it to practice. So pi on 12t, therefore, that's my quadrant 1 answer, ... How do I do the quadrant 4 answer? 2 pi minus that. So keep that in your calc and go 2 pi minus that answer. So it's 2 pi minus that, etc. So it's 0.92729 ... comma. I'm expecting 6.5 point something.
5.355. Doesn't the question say the times between 5 and 5?
Can someone explain? You do is you don't delete it. Sorry, what we should have done is you're going to have to do this one. See, so therefore the time, what do I do with this number now to get time? I have to times this by 12 and divide by pi. You okay? So you better not clear your answers. Times 12 divided by pi, and that one you'll have to redo. So you have to do 2 pi minus that times 12 divided by pi. So I need some times. So just do the first one on its own. Shift cos in radians 3/5. You'll get that, then times it by 12, divide by pi. Yeah, 3.542, but no, go degrees and minutes before you do anything else.
The other one is 20.457.
All right, 3 degrees, 32 minutes, 31 seconds, degrees, minutes, seconds, hours, minutes, seconds. So I've got 3 hours, 32 or 33 minutes to the nearest minute. Then you stop, get your calculator, unfortunately, out again, and do this one. Shift cos, get the answer, then do 2 pi minus that, you get that, times it by 12 over pi, and then
20.457.
etc. But then convert that to degrees and minutes. You know what we could do, actually? Why don't we, actually, we don't need it. What can I do instead of doing this? Girls, why don't I just subtract it from 4 a.m.? Girls, stop for a sec. Instead of doing this, I can get that one. Can you look at the diagram? Because you can't see it. I mean, all right, work it out if you want. Go. 20 degrees.
27 minutes and 28.7.
Whatever, seconds. So therefore, that's 20 hours, 27 minutes. Now, all right, that is a real pain to do that, and we don't have to do it. This is what we can do instead. We're going to look at the graph. So girls, this first one, yes, do it. The second one, we've got another way around that by looking at the diagram. So you can get it down. But for the next one, when we do 17 degrees, we're not going to do that second one, all right? Because it takes too long. Exam will be over by the time you finish it. So can I move? I'm going to look at the diagram. Girls, you know with quadrants, see this? So therefore, the times are 4 a.m. plus, see girls, look at the graph. It's 4 a.m. Time is 3 hours, 33 minutes. So you've got to do 4 a.m. is 0 time. 4 a.m. plus 3 hours, 33 minutes, which is what? 7:33 a.m. But instead of me doing this 20-hour business down here, I can add the 20 hours, 27 to the 4 a.m. Or, so I can go 4 a.m. plus 20 hours, 27 minutes, but that takes a long time and it's a real pain. And that takes me next morning, I think, to 27 a.m. on the next day. But instead of doing that, I can just do the following. Wouldn't I do 4 a.m. on the next day minus, go back 3 hours, 33 minutes. Much easier, okay? Much easier. So girls, once you've worked out that, you can add your 3 hours, 33 there, or because it's quadrant 4, why don't we just subtract it from the 4 a.m.? It's much easier.
So
That's
4 a.m. minus 3 hours and 30.
gives you the 12:27 a.m. on the following day. All right? So girls, so isn't that better? So just work out the angle once or the time once. And then let's say it was quadrant 2, you'd add it onto the 10 a.m. No, quadrant 2 is the middle. Girls, this is what you got to think about. Girls, can you look? When it's quadrant 1, it's just quadrant 1. When it's quadrant 4, isn't it 2 pi minus or 360 minus? But in this case, it's the n time minus. When it's quadrant 2 and 3, you've got to start from the middle and minus or plus.
Yeah.
Okay? Now we're going to do that with the next one, 17 degrees. Are we ready?
You say we could-
Girls, you don't add it to the 10 a.m. if it was quadrant 2. You've got to subtract it from the 4 p.m.
Yeah.
because quadrant 2 is always 180 minus and quadrant 3 is 180 plus. And this is 0, 360, 180 degrees if you're thinking of the curve. Look, we'll do 17 degrees. We have to do it now because that shows it. So 17 degrees, and draw the graph again. But girls, it's really good that we did this because it really shows all the different types. I know, so we've got 5, 0, -5. That's 19, that's 14, that's 9 degrees. If you want 17 degrees, it's up here. No, it's not 4. It's 2 degrees less than 19, it's 3. So I'm going to work out both times so that we can practice doing. So girls, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. So find T when X equals 3. So we've got 3 equals, girls, it's the same angle, so don't worry. 3 equals negative 5 cos pi on T. Pi on 12T. So -3/5 is that. So it's just quadrants 2 and 3 where cos is negative. We know the acute angle already. Acute angle pi on 12 is that 0.927 business. Do you remember? And we worked out that T, we already worked it out, was 3 hours, 33 minutes. from the other part. You don't have to do it all again, all right? Do you remember?
Yeah.
All right, so now how do I do it? This is 4 a.m. The middle one was 4 p.m. So to do the first time, this time here, I'm going to go time 1 and time 2 to minus, that's right. Time 1 is 4 p.m. minus 3 hours, 33 minutes, which is what? 12:27 what? p.m. Thank you, in the afternoon. And time 2 is 4 p.m. plus 3 hours, 33 minutes. So girls, that's like the part before to get that. And it's 7:33 p.m. So therefore, and it makes sense if you look at your diagram. This time is more than 10 a.m., is it? It is. It's 12:27 in the afternoon, makes sense. This time should be less than 10 p.m. and it is. It's 7:33 p.m. in the afternoon. So when you do question 24, which is the tide question, you'll have to, the boat will be able to go into the harbour, say, when the water's a certain depth, and you've got to be able to do 2 quadrants at a time. All right? So your homework is going to be to work on that sheet. I've sent you fully written out solutions for exercise 3D. Do what you can tonight. Tomorrow we're doing the next exercise, but it was really important that we got this done.